This is lesson 7.2, dividing monomials. To divide powers with the same base, you subtract the exponents. Here is your rule. A to the m divided by a to the p equals a to the m minus p. Let's practice this skill. C to the 11th power divided by C to the 8th power equals C to the 11 minus 8, which would be third power, C cubed. Number 2, x cubed y to the 4th divided by x squared y equals, let's divide our x's first. X cubed divided by x squared is x to the 1st power, or just plain x. Y to the 4th divided by y to the 1st power. Let's recall that every variable has an exponent. Y to the 4th divided by y to the 1st would be y cubed. Number 3. K to the 7th, m to the 10th, p, divided by k to the 5th, m cubed, p. Okay, let's divide the k's first. K to the 7th divided by k to the 5th would equal k squared. M to the 10th divided by m cubed would be m to the 7th power. And p to the 1st power divided by p to the 1st power would be p to the 0 power. And they both cancel each other out, so it equals 1. And there's no need to write the 1. So your answer is k squared, m to the 7th power. Let's continue. To find the power of a quotient, first you find the power of the numerator, then you find the power of the denominator, and then you simplify. If I have a over b being raised to the m power, it equals a to the m over b to the m. Example number 1. 3x to the 4th divided by 4. It equals 3 cubed x to the 12th divided by 4 cubed. Now let's simplify. 3 cubed is 27. X to the 12th divided by 4 cubed, which is 64. And if you can reduce, remember that you must. In this case, you cannot simplify. Okay, number 2, 5x to the 5th y over 6. And all of that is being squared. So we have 5 squared, x to the 10th, y squared, over 6 squared, and let's simplify. Be 25, x to the 10th, y squared, over 36, and you would reduce if possible. Number 3, please hit pause and work that out on your own. Go ahead and check your answers. Okay, moving along. The zero exponent property. Any base raised to the 0 power equals 1. A to the 0 power equals 1. That means that any number, any variable, raised to the 0 power is equal to the number 1. So let's practice. 15 to the 0 power is equal to 1. 2/7 to the 0 power is equal to 1. Negative 4n squared q to the 5th r squared over 9n cubed q squared r, all of that raised to the 0 power is equal to 1. Let's do number 4. We have b to the 4th, c squared, d to the 0 power over b squared c. Let's go ahead and divide the b's first. B to the 4th divided by b squared is b squared. C squared divided by c would be c. And d to the 0 would be 1. Times 1 would be an invisible 1, not necessary to write it. Okay, let's move on now to the negative exponent property. A to the negative n is equal to 1 over a to the n. And conversely, 1 over a to the negative n is equal to a to the n. Notice that what happens when you have a negative exponent is that the term goes to its opposite place. If it was in the numerator, it'll come down to the denominator with a positive exponent. If it's in the denominator, it's going to come up to the numerator again with a positive exponent. So let's practice writing these monomials with a positive exponent. If I have 2 to the negative 4th power, it would be 1 over 2 to the 4th power, and we can always simplify. 2 to the 4th power is 16, so the answer would be 1 over 16. Number 2, 1 over j to the negative 4th power. In this case, the negative exponent is in the denominator, so we need to write it in the numerator with a positive exponent. So it would be j to the 4th power. Number 3, n to the negative 5th power, p to the 4th, divided by r to the negative 2. So let's set up our problem, and let's work with n to the negative 5th power. That would become n to the 5th power in the denominator. P to the 4th power already has a positive exponent, so it can stay where it is. And then r to the negative 2 is in the denominator, but we need to write it with a positive exponent, so it's going to move up to the numerator with the positive exponent. Number 4. 5 r to the negative 3 t to the 4th divided by negative 20 r squared t to the 7th u to the negative 5th. Okay, let's work on this one step at a time. Let's start with the coefficients. 5 over negative 20. That can be reduced to negative 1 over 4. Now let's deal with the r's. R to the negative 3 over r squared. Well, let's recall that we're dividing here. R to the negative 3 divided by r squared would become r to the negative 3 minus 2. Negative 3 minus 2 is negative 5. It would be r to the negative 5. Okay, now let's divide the t's. T to the 4th divided by t to the 7th would be t to the 4 minus 7. 4 minus 7 is negative 3, so it would be t to the negative 3. And then u to the negative 5 is on the bottom, in the denominator. So now let's take care of our negative exponents. Recall that when you have a negative exponent, you change its position, put it in, if it's in the denominator, it goes into the numerator, and you change the negative exponent to a positive. If it's in the numerator, you bring it to the denominator, again changing the exponent sign. So let's start with the coefficients will remain the same, negative 1 and 4 in the denominator. R to the 5th power needs to come down to the denominator with a positive exponent. T to the negative 3 is in the numerator. We need to bring it down to the denominator again with a positive exponent. And then we have u to the negative 5. It's in the denominator, so we need to bring it up to the numerator with a positive exponent. So that would be our answer, and it is simplified. Go ahead and work on number 5 on your own. Hit pause on the video and then check your answer. The answer is 8 over a to the 11th b squared c squared. I have attached some extra practice problems for you to do independently. So for today, go ahead and work on number 1, number 5, number 6, number 9, and on this next worksheet, you will work on the following problems. Number 2, number 7, number 8, and number 12. Please write down any questions that you have, 3 questions that you might have, so that we can discuss them in class tomorrow. I hope you have a great night. God bless you. See you tomorrow.